Great. We are going to consider the topic partial fractions. Partial fractions. And if we look at this side, we've seen that we have the explanation there. And so we are saying that partial fractions is a technique used in algebra to break down a complex rational function into simpler fractions that are easier to work with. And so that is the meaning of partial fractions. And we are going to deal with the various aspects of them. So first, we want to deal with what we term as the linear factors as the denominators. So we have this rational function. And if we have linear factors here, then we can break it down in this way. So there's a general convention. So it will be A over this factor and then B over that factor. So we've been able to decompose this into partial fractions. Now we are yet to look for our A and B, and then we'll come back and slot them in. So this gives us the partial fractions for this function. Right, so let's look at some examples. Express this function, rational function, in partial fractions. So solution, as indicated above, we write this to be equivalent to A on x plus 1, then B on x minus 1. Then the next step is that we are going to multiply the whole of this by the denominator. And so we shall get 3. When we multiply the whole of this by the denominator, so it will be x plus 1 into brackets, and then x minus 1 into brackets times the whole of this, so it will divide. Then we multiply A over x plus 1 by this as well on this side. And so this will divide, and we shall get A into x minus 1. Then the whole of this, we shall multiply this by that over here. And so x minus 1 will divide that. So we shall get B into x plus 1. So we've been able to clear the fractions. Now I want to look for our A and B. For us to look for our B, we need to eliminate A. So when we put 1 here, this becomes 0. So we say that let x be equal to 1 to eliminate A. So when we do that, this goes to 0, and then we get our 2 here, so 2B, then our 3. So 3 equals 2B. We make B the subject, we shall get 3 on 2. So our value for B is 3 on 2. Now we substitute -1 for x, so that I'll be able to eliminate B. So -1 here plus 1 gives us 0, so this goes to 0, we get -2 here. So we shall get 3 equals that, and that gives us 3 equals -2A. Now we make A the subject. So we divide both sides by -2, then we get -3 on 2. So that is our A. Now we come back and do the substitution. We come back and do the substitution. Now we've all seen that we started with A being, that is A over x plus 1. So over here, because its value is negative, we'll then take it to the side. And then our B also gave us 3 on 2. So 3 on 2 into x minus 1, and then with this one. So that's how, so this is our B, and this is our A. B is 3 on 2, and A is -3 on 2. That brings us here. So that's how we actually work with this aspect. Let's look at another example. But before then, you can go through, look at the questions. First, I defined partial fractions. And I said that we are going to deal with the linear factors at the denominator. And when that happens, this is how we actually write it down. Then this defines partial fraction. All right, now I've also explained this example. So just take your time and go through. Right, let's look at the second example. Express x squared minus 2x plus 4 all over 2x into x minus 3 and then x plus 1 in partial fractions. So we write the whole thing over here. So we have 3 linear factors. So we say that A on 2x, B on x minus 3, and C on x plus 1 from here. Now we are going to multiply every term on the left-hand side and then every term on the right-hand side by the denominator. When we do that on the left-hand side, the whole of this will be cleared, so we shall get the numerator. When we come here, we multiply a over 2x by this, then it's the 2x that will be cleared. Then we'll be left with this one. That's why we have a into this. Then over here, it's only the x minus 3 that will be cleared. So we get 2bx, x plus 1. And then over here too, we shall get our x plus 1 being divided here. And so what will happen is that will divide. So we shall get our 2cx, x minus 3. And so this is what we normally get. So we are going to use this to find our values for A, B, and C. Now, for us to get B, we need to clear our A and C. Okay, so what we are going to do is that we are going to substitute 3 in for x. And when we do that, this will clear and that will clear, and we'll be left with what we have, B in it. Okay, so we put 3 here, put 3 there, and then we put 3 here, put 3 there, 3 there, 3 here, and 3 there. So this will be clear, that will be clear, and then we'll be left with this one. So over here, we put 3 there, and so we get 4, there's a 3 here. And so we move on, then times our 2, that gives us 24b. Then with our 3 squared, then 3 times 2 negative plus this, we shall get 7. Then we divide both sides by 24. So our b will give us 7 over 24. So we've gotten our b. Now, when we substitute -1 for x, then it means that -1, this will be cleared, -1, this will be cleared, and this one will stay. So it means we are looking for our c. And so -1 squared, then -1 times -2 plus 4. So this one will compute to get 7. Then we get our 8c from here. So when we come here, we are putting in our -1. And so basically, when we do that, we get straight our answer. We also have our -1 here, so we shall get a positive value. That's why I have the positive 8c. We make c the subject, so c is equal to 7 on 8. The next step is that we want to look for our value again. Now, for us to get our A, what we need to do is that we can compare coefficients. So here we are going to compare coefficients of s squared. We can use other means also to do it. We can also put x to be equal to 0, and then we substitute the values that we have. That also give us the answer. And so comparing coefficients of s squared, we have A, we have 2B, we have 2C, and that will give us 1 from here. So coefficient of s squared, so x times x, s squared, so as squared, 2 times b, x, so 2bs squared, and then 2cx times this x, will get 2cs squared. So, and that will be equal to the coefficient of s squared here. And so that's why we have it equal to 1. Now we know our b is 7 over 24, so 2 times 7 over 24 plus our c is also 7 over 8, so 2 times 7 over 8. So when we compute this, divides that 12, and then we get here. Then we use LCM to simplify this. Then we shall get 8 plus 20. 8 plus 28 over 12 equals 1. And then when we reduce it to its lowest terms, 4 into this is 7, 4 into that is 3. And so our A is neg 4 on 3. Now, when we get back here, we are going to put 3, that is 4 on 3 times 2. So 4 here, then 3 times 2. So these two divided 4. And that is why when we wrote everything, we got 2 on 3. Because there was a 2 down here and there was a 4 up there. So that 2 will divide. And so we got 2 on 3. That is why. So we now do the substitutions. And that gives us this value. All right. Let me go back for you to look through. So this is the question. And look at how I explained, look through it carefully. Take your time. It is a gradual process. Align yourself to the explanation I gave early on. And then we came to the aspect where we want to get our C. Then here we compared coefficients. All right, so that does it for linear factors. Another time, we'll consider another aspect as well. Thank you so very much for your time. and you can continue to solve more questions under this until you get grounding